Our class, you are very much welcome to our class of today. My name is Muviru Richard, and today we are going to look at probability. And probability measures the chance that something will happen. It gives a structure to the idea of chance and allows us to measure the level of uncertainty or chance for something to happen or not to happen. Probability of risk will inform decision makers. That is one of the uses. Decision makers, the choices to be made in the future. So you make future decisions based on what has happened or what has been happening. Another use that can be used in any investment or project to determine how likely an investment will be during the thinking stage. So any investment, you have to judge its future proceeds or outcomes basing on what has been happening. So any project, you have to predict when you are coming up with an investment or project, its likelihood of its survival, of yielding profit, so that the decisions can be made during the thinking stage in order to avoid any losses or incurring great loss at the thinking stage. Thinking stage is a stage you sit in such methodology whereby you start off by designing, think about what you are going to do. And it is probably the best option if you stop taking on that project at that stage, because you haven't incurred a lot of investment in it. So it's in that when you decide whether you make a loss or gain in future, and if it is a loss, then you don't invest. Let us see some of the terminologies used in probability. We have an experiment like any other science related course. You've done some experiments, but in probability, when we talk of an experiment, we are talking of a situation that can be performed to gain information. Example, when you toss a coin, you are performing an experiment. When you roll a die, when you write an examination, you are performing an experiment. You are taking part, not part in a raffle. When you are taking part in a raffle is when you participate in a raffle, you are performing an experiment. Picking a student from a class randomly, whatever method you can use, you are performing an experiment. An outcome set. Another terminology used in probability, and we shall use them, by the way, when we come to calculation. An outcome set is a set or list of all possible results associated with an experiment. When you toss two coins, that spreadsheet you see is when you toss two coins. A coin has either head or tail, and on the one side you have maybe coin 1, and the upper side you have coin 2. So when you toss, you can either get a head on the first coin and head on the second coin, or you can get a head on the first coin and a tail on the second, or you can get a tail on the first and a head, or tail. So those are four possible outcomes. So tossing a die. A die, I think you people, you have ever played that game called Ludo. And you know a die. A die has 6 holes. On each side there are holes. One side has hole 1, then 2, 3, up to 6. So the total number when you toss one die, possible outcomes are 6. But if it becomes 2 dice, we don't call 2 dice, but we call it 2 are called 2 dice. Die 1 and then the other one is die 2. You can make a spreadsheet that on die 1 you can get 1 with 1 hole, and then the second one with 1 hole, with 1 hole with 2 holes, with 1 hole with 3 holes, up to 1 hole with 6 holes. Then when you fill it, and I would like you to go and fill it by yourselves, you will get the last one will be the die with the 6 holes, and then on die 1 and 6 holes on the die 2. So there are 36 possible outcomes when you toss 2 dice. What do you mean by equally likely outcomes? These are the ones with the same chance of occurrence. So if you are tossing a coin, you can get a head or tail. So that means the chances of one appearing on top are the same. We shall come to calculation of those probabilities, and you say it is 1 over 2. So whether getting a head or tail, the chance is the same, even rolling a die. So when you roll a die, the chances are the same of either one appearing up 2 or up to 6. And that chance you will see that when we come to measuring, it is 1 over 6. So each one has the same chance of appearing. Then what is an event? An event is either a single or combination of outcomes. Again, tossing a die, let the event be getting an even number. So when you toss a die, the event is getting an even number. So the event we shall be having 2, 4, and 6. Those are even numbers. So number in E, N stands for number. Number of those events are equal to 3. So in tossing a die, another example is let the event, not even, but the event be getting a sum of 5. So getting a sum of 5, you can either have a 1 on the first die and 4, or 2 and 3, or 3 and 2, or 4 and 1. So 1 and 4 and 4 and 1, those are different, because 1 and 4 means 1 hole on the first die and 4. Then 4, 1 means 4 holes on the first die and 1 on the second die. So you'll find that number of events will be 1, 2, 3, 4. So the total number of events will be 4. So the probability of an event to occur is represented by probability into E, which is equal to, that is the formula we'll be using, total number of events over the possible total number of outcomes. So in order to calculate the probability, you will have number of events over total possible outcomes. So when you are rolling in tossing a die, getting a sum of 5, if the event is getting a sum of 5, and you are tossing 2 dice, you will get the upper pattern. You say we have already seen that those are 4. Number in E, the possible total number of outcomes, number of events are 4, that is getting a sum of 5, but the total possible outcomes are 36, because it is up to 6. So the probability is 1 over 9, or not 1, or 0 point. You put a 0 point somewhere there, not 111. It is 0.1111 when you divide. So complement of an event. A complement, given an event A, that one in red, the complement of A is represented by a dash. There is a dash up there, which consists of all sample points that are not members of A in an experiment or outcome. So that means all non-members of A are the complement of A. And it is given, there is a formula for that. Probability of all the events plus the probability of non-members of A appearing, it will give you 1. So 1/9 we have seen that is in the previous example, that is the probability of getting a sum of 5, which is 1/9. So getting a sum of other additions, if 2 are tossed together, is 1 minus 1/9, and that will give you, it will give you 8/9. So getting other sums. Scale of probability. Probability are measured on a scale between 0 and 1, inclusive. So whenever you are calculating anything in probability, it must be between 0 and 1. Anything out of that measure or that scale, you are not measuring probability. You can't say the probability is 2.5. That one will show as if you have never been in a class where probability has been taught. And if for example, you go for post-graduate course and you go outside this country, you go to Ghana, Nigeria, and someone calculates a probability and you burst in the class and you say 2.5, they will laugh at you. Or you say it is a negative 1.6. There are no negative probabilities. So the scale is measured between 0 and 1. Or you say the probability is 5/3. 5/3 gives you a whole number, and it even surpasses it. But it's 3/5, yes, because that one, if you go into decimal points, it will be 0.6, and that will be below 1, but positive. So you can see that we call it inequality. Probability of any event is less or equal to 1 and greater or equal to 0. So all positive decimals, percentages which don't exceed 100%, and positive fractions which don't exceed 1 are possible answers of probability. So the scale is drawn down there. Up there is 0, then in the middle is 0.5, and then 1. So if you change it to percentage, 0% and 50% and 100%. 0% means something is impossible. It can't happen. For example, the possibility of winning a raffle when you have no ticket is 0. Probability is 0, because you can't win a raffle when you don't have a ticket. Or probability of selecting a black ball from a bag full of white balls. Although we used to call them what when we were still young, and I can't know how they used to do it. Those traditional people could put white balls and then it picks and it shows you the bag and it's all white, and then after that the man turns the bag up, and then it gets out a red one. That one is out. If probability of an event is 1, the event is certain. That means it is 100% sure that it will happen. For example, probability of selecting a red ball from a bag full of red balls is 1. So the sum of all probabilities associated with an experiment is equal to 1. So that means probability of any event E plus probability of event 1, event 2, probability of event 3, event 4 plus the last event will give you 1. So when you are performing an experiment. There we missed out. I was just summarizing it, that probability of summation E I running from 1 up to n is equal to 1. So evaluating probabilities. That is, probability of an event is equals to number of ways an event can occur, divided by total number of possible outcomes. There is a slash there. You divide by total number of possible outcomes, then you get the probability of an event. And I've already given it to you in the previous slides. I'm giving you an example. Suppose an experiment X consists of rolling a 6-sided die and noting the number of spots showing on the top face. That is the set of the outcomes, the total possible outcomes of 1, 2, 3, 4 up to 6, which are equal to 6. So the probability of getting 1, getting 2, getting 3, getting 4, getting 5, and getting 6 is equal to 1 over 6. So those are equal likely. So when you add all the possible the probabilities of each of that event, you will get 1 over 6 plus 1 over 6 blah 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 blah, which will give you 1